linear distance away. And it actually does in the procedure tell you exactly what the distance is between the thermocouples. So basically that's how you would be able, when you're right on the y-axis, the temperature is going to be the maximum at the heater, and then the farther away you get, it's going to drop. And all the different data sets will basically look like they'll be parallel lines, essentially. And that's it for this one. You can go ahead and hit stop. So just by using the actual tap, you can control it with this. I would imagine this is a little more temperamental, more sensitive rather than that. So if you can ballpark it with that and then fine tune it with this, that's probably about the best bet. And then I'm going to have to unplug all this stuff and we'll set that one up. What we did with the axial unit, we're going to start out with a set flow rate, and then we're going to maintain it the whole time that we're collecting data. Go ahead and turn on the heater. Like, touch the yellow, basically, just get it right up to the yellow. And that should be around 10 watts, give or take.
10.8.
Cool. Is the flow reader meter reading anything?
2.7 liters per minute.
Cool. Okay. So again, all of a sudden now magically the flow sensor actually works. It's just one of those things. But in any event, instead of the heat conducting axially like the other one, this time it's going radially.
So exciting.
And just like before, when we first turned it on, everything is at room temperature. So when you first start putting heat power into the system, it's going to gradually build until it reaches a steady state. So after a few minutes, all the temperature readings will settle down, and if it fluctuates just a little bit, that's fine. You're probably going to be just more concerned with one specific point versus all of them anyway. So as long as you basically see some consistency, you'll know you've hit steady state, and then you would record the data in the table that's posted in the manufacturer's instructions. So this would be the first of 6 steps for this experiment. For the next step, you would increase your heat power again by 10 watts, wait for steady state, record your data, and then you keep walking it up by increments of 10 until you hit 60. So again, you'd be able to plot your data and generate trend lines to show the trend. Obviously, you're going to be hotter closer to your heat source, and the farther you move away from it radially, the cooler you will be. And then with the second experiment, it's very similar to what we did with our axial unit. We're going to start with a fixed power, so we'll call it 30 watts. And then we're going to start out with an initial low flow rate that we are controlling with our needle valve. And again, we're going to wait for steady state conditions. We're going to write down all the thermocouple readings and everything else that we need in our table. And then we're going to increase the flow rate of the water and basically just keep repeating. And then you'd be able to also generate trend lines, and that's essentially it.
When we do this the third time, it goes pretty smooth and pretty fast. So.